we're going to do science now, and if you look on page 47, we're going to talk about matter. Okay, remember we talked about matter on Friday. Let's get our little chart out so we can look at it. Alright, we said there are 3 different states of matter. They are solid, liquid, and gas. And we said solid is when the molecules are packed tightly together, right? Everything around you is made of matter. Remember, material is made up of molecules that have weight and take up space. So the definition of matter is material made of molecules that has weight and takes up space. And we talked about even the air in the room, even though you feel like it doesn't have any weight, we know it does, because if you blow up a balloon, it takes up the space in the balloon, and then when you let the balloon go, it will fall to the ground, right? Alright, so a molecule is a tiny particle of matter, so all matter is made up of little tiny particles called molecules, okay? All matter is made up of molecules, right, Michael?
Yeah.
Okay. I don't know what you're looking at, you need to be looking up here, please. Okay, so can you see a molecule with your eye? No, you have to look through a microscope to see a molecule. And property is what you talk about, the way to describe matter, okay? Matter has different properties, okay? Part of it would be the fact whether it was solid, liquid, or gas. That would be one of those properties, right? Alright, so we're gonna look at some different forms of matter, and we're gonna talk about their properties. And I had one more I wanted to get, but I was waiting until sooner, so I don't leave it out. That long, not that it's spoiled, but anyway. I have a variety of objects, and we're gonna look at these variety of objects, and we're gonna discuss the different properties they may have. Alright, so if you're on page 47, they have some things that we could look at, and I did not get all the things that are on this list, I just got a variety of my own, alright? So, first of all, we have material, alright? Like, what is the material made out of? Alright, this one actually includes more than one material, because you have the outside material. What would that be made of?
Plastic.
Okay, there's paper, actually it's more than one. There's paper, there's plastic, alright? Is paper a solid, a liquid, or gas?
No.
Yes. Which one? Solid, liquid, or gas?
Salad.
It's a solid. Alright, so paper is a solid. Is plastic a solid, a liquid, or gas? Solid. What about the drink inside that?
Liquid.
Yes, that is liquid, alright? So we have 2 solids, the paper, that's the wrapper, we have the plastic, that's the bottle, and then inside the bottle we have liquid, okay? Alright, now, do they all have the same properties? No. If you were to come feel this, Joey, you're the only one, come feel this, don't come to. How does it feel?
Hard.
Okay, the bottle is hard. Can you describe it in another way? Leanna, come feel it. Can you describe it another way besides hard? It's cold, because I've had it in the refrigerator, so this matter is cold. It would be the liquid inside it that's cold, okay? As soon as I pour the liquid out, after I just leave it sitting out, it's going to start warming up, right? Because the air out is not as cold as my refrigerator, but it's cold. What's another way you could describe this bottle? Besides being hard, it is, okay, I guess sort of, little,
Smooth.
it's smooth, okay? But if you were to feel this lid, bumpy. The lids are made bumpy so that you can have something to grab as you try to open it, okay? So they're not as smooth as the rest of the bottle. Alright, what about the plastic? Could I just easily grab this plastic and tear it?
No.
So it's more durable, but what about this paper? Could I tear it?
Yes.
In fact, well, actually it's not quite paper. It is not paper. It seems like paper, but I don't think it's quite paper, so it does not tear as easy. But which one would be easier to break or tear?
Paper.
Yes. This is more of one of those plasticky kind of papers.
Rubber.
Alright, so it's not tearing as easily as I thought it was going to. I think they make it that way because condensation would make real paper disintegrate, right? You know, if you put real paper in water, then it disintegrates, right? Alright, which brings me to this. This is cardboard, alright? Is cardboard solid, that's not very hard. I could take it, I could rip it if I wanted to, but I don't want to rip it, right? So, what about this one? Solid, right? This is a solid. What's it made of? Wood. No, that's wood. Wood, right? So this is wood. Now here, this one is also an apple. Thank you. This one is also an apple, just like that one's apple, but is it made of wood?
No.
No. Is it solid, liquid, or gas?
Solid.
What's it made of?
Glass.
I'm not really sure if that's some kind of glass or some kind of stone, but anyway, it's very heavy.
Just real quick, Julie's asking that you turn that back in when you get done with it. Okay.
Okay, I will be done with it when I get
Yeah,
out of this unit.
I got you.
I need it for this whole math unit.
No, that's fine.
Yeah.
You could use it for the whole week if you need to.
Okay.
I'm just saying.
Right, thank you. Alright, let's move on to this one. This is
Play-Doh.
Play-Doh. Is Play-Doh a solid?
Yeah. Yes.
Alright,
So soft.
is it liquid?
No.
Is it a gas? So
No.
it has to be a
Solid.
but if I can ever get it out of here, it is
Squishy.
okay, that word is pliable. Could I take this cardboard and smush it?
No.
If I were to squish it, which yes, you really could, if you literally think about it, if I were to put it on the floor and have somebody hold it, I could step on it. My weight would squish this and ruin it. I could ruin this piece of cardboard. But is it easily? Is it easily squished? No, not easily. Alright, but can I easily squish this?
Yes.
But unlike a liquid, where if I were to pour that drink out, would it just sit there in the same shape as the bottle? No, it would run all over the floor. It does not hold its shape.
No.
This one, as I squeeze on it, it holds its shape. Alright, even though it's pliable and I can squeeze it into different shapes, alright, it's still a solid, it's just a pliable solid. Because after I leave it alone, it would just sit there like that. Okay? Yes, you're right. If I left it out long enough, instead of putting it back in its container, it would dry out and it would get hard like a little rock, wouldn't it? How many of you ever had Play-Doh and you didn't put the lid on it good and it got dried out like a rock?
Yeah.
Right? But I have tried to make sure I put the lid on this really good every time, so it has not dried out yet. Alright, let's go with this. What's this made out of?
Plastic.
And is it solid, liquid, or gas?
Solid.
Alright, could we manipulate this? Is it
No.
metal? No. Alright. What about this? What is this? We're not talking about the bottle. Let's not talk about the bottle. Let's talk about what's in the bottle. That would be a liquid. How would be a gas, buddy? Is it a gas?
No.
Alright. So it is a liquid. If I were to pour it out, it would run all over the place. Now, is it the same consistency as this?
No.
This one moves around very quickly, but glue and also this one. Is this a liquid?
Yes.
Yeah, it is, but again, it's like the glue, it takes it longer to flow, okay? It would flow. If I were to put it on its side, then it's going to flow down into the container until it's no longer this way, but it would be this way. It's just not the same consistency as this liquid, but it is still liquid. You can make it flow out of the container, you can make it take a different shape by putting the container a different way. In fact, I'm gonna leave it like that so they will both flow. I have one more. Oh, I had two more. I forgot to show you this one. Who knows what this one's made out of? It is a stapler. I didn't ask that. What's it made of?
Plastic.
There's
Metal.
some plastic on here, but this is actually, you hear that? Yeah, that's metal, and it does have a rubber base so that it doesn't make so much noise when you sit it down on your desk, okay? But it is made of metal, okay? So that is metal. Do you see some that even though they are made out of different, have something else in common?
You could freeze the water in a freezer and it can turn to a salad.
That's true. That is not what we meant by having common, but you're right. You could change this matter from a liquid to a solid by putting it in the freezer. How could you change this liquid into a gas? Yes. Yes, by heating it on the stove. But what I'm asking is, do any of these things have something in common?
They're all solids.
All of them are not solids, because this one was liquid, and this one was liquid, and this one was liquid. Do you see another property that they might have in common? Grant?
They're all metal.
They're not all metal. This one does have a metal leaf on it, and this one is metal,
You
but
said
this one's
matter, not metal.
matter? Oh, I'm sorry, I thought you said metal. Yes, they are all matter, so they have that in common. I'm talking about one of their properties. What property can you visualize and see that they have in common? Some of them are the same because they have the same.
Is it material or something?
Does this one, and this one have the same material? So they have the same what? I'm even pointing out the ones that I think are the same. What?
Colors.
Color, yes. Even though they're made out of different material, notice these three are very, very similar in color. Alright, so sometimes matter can have a similar color. Alright, what about this, which is my kinetic sand, and the Play-Doh? Do they have a similar color?
Yes.
Yes.
And
And
they-
they green, you know, they're not the same shade of green, but they are both green.
And
Alright, what else do Play-Doh and kinetic sand have in common? Michael?
squeeze them both.
Yeah, they're both pliable. That word is pliable. Let me say that word. Pliable.
Pliable.
So the kinetic sand and the Play-Doh are both pliable, and they would stay like that.
Their shape.
Kinetic sand would just sit there. Okay? Yes.
The glue and whatever the green thing is, they're
Yeah,
sort
that
of
is
the same.
moisturizer. Very good. So what are you saying about it again?
That they like, it takes longer for them to flow, so they're
Yeah,
sort of the
so
same.
they have a different consistency than this liquid, but they do have a similar consistency. Although, if you could see, I can see through this. Can you guys see through this if I bring it to the light?
Maybe.
Can you see that my glue has already flowed this way?
Oh, I can see.
So you can see the line
Yeah.
right there? Alright, I don't know if the camera can pick that up, but you can see that the glue has already flowed, as you can see where it's this way. But this one, has it flowed?
No.
Not completely, but it is. You can see it creeping down here a little bit. Alright, you can see that it's creeping down very slowly. So even this is a thicker consistency than the glue. Since the glue already flowed down, and this one is still trying to flow down to the bottom. It's just a very, very thick. But if you look, and you can see that it's sideways. Can you guys see? Okay, so it is actually starting to flow down, isn't it? Yes.
Isn't there something that's a solid and a liquid?
Yes.
Or?
No.
I forget what's
I can't remember what it's called either, but there is something that, mercury. Mercury is the stuff that's in a thermometer, the kind of thermometer that you put in your mouth,
Yeah.
alright? And it shows this little line of what if you have it's a very old fashioned way to check your temperature, alright, and it has a substance called mercury in it. Alright, I think mercury is considered a solid and a liquid. Alright. Alright, go ahead and turn to page 48. Let's read page 48. On page 48, we're going to talk about liquids now. Yes.
I had two things. So there was one that was in common, and there was also a thing called oobleck that you can play with. Like if you hit it really hard, then it stays solid. But if you put your finger on it and it just stays, it goes down.
You know what? I've seen that stuff. You make it with like baking soda or baking powder or something like that. Yeah, I've seen that.
And also like the purple dragon thing sitting on like an alligator or something, and that are both plastic and they're sort of the same color.
Yep, that's true because it has green and that's plastic. Yep. So there's another thing they have in common.
I thought Mercury was a planet. It is.
Okay, there's more than one Mercury. There's Mercury this planet. There's Mercury. It's an element on the periodic table. Yes. We need to move on. I'm videotaping
Will
soon.
we do salt dough this year?
We use what?
Salt dough. Do you know what that is?
Salt dough. I do know what it is, but I have no reason to do it.
I was gonna say, why can't we read this like we do in our reading?
solids. If you look around you, solid matter is the easiest kind of matter to find. Your desk is made of solid material. At the playground, the equipment you enjoy is also made from solid materials. Oh, I'm on the wrong page. I'm sorry. Page 48, liquids. Sorry, I turned back to look at something real quick because somebody was asking about something. Other kinds of matter do not have shape. Liquids cannot hold their shape, but can fill the shape of a container instead. You can find plenty of liquid matter in your kitchen. Orange juice, milk, oil, vinegar, and syrup are all liquid matter. The space a liquid takes to fill up the shape of a container is its volume. So what is the space a liquid takes to fill up the shape of a container?
Volume.
We use measuring units such as cups, pints. That word is pints, guys. Quarts and gallons to measure liquids. These are English measures. In science class, you will probably use a beaker to measure liquids. Beakers usually measure in metric units such as milliliters and liters. I'm sure you're familiar with the word liters from soda. Soda comes in a 2-liter bottle, right? All liquids have the property of being able to flow. They can spread out to fill something because the molecules in them are not packed tightly together. Instead, they are loosely connected. All liquid matter can flow to fill up a container, but not all liquids feel the same. Some liquids pour out more quickly than others. Molasses pours very slowly, while the water we drink pours out very quickly. Alright, on the top of the next page, it's talking about looking at sugar and salt with a hand lens. And I don't have sugar, and I don't have salt, and I don't have a hand lens. But think about it. Do sugar and salt look very similar?
Yes.
Yes, they do. Alright, they're both a solid, but they have different tastes. Alright, very different tastes. And if you were to make cookies and you were to scoop up a cup and a half of salt instead of a cup and a half of sugar, would you be able to eat those cookies? No. So they do look very similar, but they are not the same. Alright. What would both of them do if you put them in a liquid like water though?
Will they evaporate or something?
It's not called evaporate. They do disappear, but they're not evaporating. Evaporating is when liquid becomes a gas.
Dissolve.
Dissolve, very good. They would both dissolve. If you were to put salt in water and stir it up, put sugar in water, stir it up, they would both dissolve into the water.